So what I'm going to do, I'm just going to start by running through what sickle cell is. I know you all know, but it doesn't hurt to just go through it again each time. And I'm really going to focus on what aspects of sickle cell cause bone problems, and then also some of the genetics that also have an effect on the bones. I'll briefly mention about normal bones and how normal bones look, and then we'll talk about some of the common complications in sickle cell disease, and really focus on the avascular necrosis. So just to start, to make sure we all understand the same thing about sickle cell. Sickle cell, as you know, is a problem with the red blood cells, which are made along with the white blood cells and platelets in your bone marrow. That's your factory for your blood. And the problem with the sickle cell is the hemoglobin production inside the red blood cells. And your normal hemoglobin consists of two different sorts of chains, alpha chains and beta chains, and you have two of each in each hemoglobin molecule. And the problem in sickle cell is with your beta chain production. That's where the genetic change has happened. And you don't make normal beta chains, you make sickle beta chains. So how does that affect your ability to have normal hemoglobin? Well, actually, if you're well and everything's going fine, it doesn't have too much of an impact. You'll see on the far left, this is someone's blood with sickle hemoglobin, but there's lots of oxygen flowing around. So your hemoglobin is actually fairly normal looking. And if you look down the microscope at someone's sickle cell, you will see lots of normal shaped red blood cells. And the issue is what's happening to that hemoglobin. So when your body gets stressed, that's usually infection, cold weather, very warm weather, psychological stress, your hemoglobin then changes properties and it becomes sickle shaped. And the effect of that is twofold. So at the top, you have blockage of your blood vessels, the vaso-occlusion. So your blood cells get very sticky, they block the circulation, that's what causes your acute pain episodes. And at the bottom you have the second aspect of the sickle cell, which is the hemolysis or the breakdown of red blood cells, giving you that bilirubin, which is yellow. And really for today we're going to focus on the top one, the blockage or the vaso-occlusion of the vessels, because that's what's important in AVN. So there's been a lot of interest recently in trying to tease out which patients have more of the breakdown of the blood cells and which patients have more of the vaso-occlusion of the red cells causing their disease. And the vast majority of patients are in the middle here. They have some aspects of their sickle cell that's due to hemolysis and anemia, and they have some aspects which is due to the vaso-occlusion of the blockage. And you'll see that on the far right-hand side is you have a list of the complications you get from the blockage. You get your acute pain, you get acute chest syndrome, and you have your avascular necrosis or osteonecrosis. And these are all symptoms that cause pain. Whereas at the other end of the spectrum, the breakdown of red cells often causes some painless complications. Just because they're not painful doesn't mean they're not serious. Now, if you just go back to the genetics, because this is quite important in avascular necrosis, and we talked about the sickle gene being making your sickle cell and your beta chains of your hemoglobin in your red cells. But if you go back and have a look at the other chains that you make, the alpha chains, they're also important. There are some individuals who don't make the normal amount of alpha chains, they have something called alpha thalassemia. And if that's your case, your blood, if you put it in a test tube, will look like this, compared to someone with normal hemoglobin like myself who would have very similar blood. You compare that to someone with sickle cell who makes normal amounts of this alpha chain, their blood is much thicker and it drops to the bottom of the test tube. So if you make normal amounts of this alpha chain, your blood tends to be thicker, you tend to have more sickle inside your red blood cells. Your blood cells don't bend as they go through circulation as well. And so you also get more destruction of your red cells. And this is thought to protect you against avascular necrosis. Whereas if you're lacking your alpha chains as well, your blood tends to last longer, it doesn't get broken down, so your hemoglobin is often a bit higher. Your red cells will stick in the circulation a bit more. So what we found is that patients who've got alpha thalassemia as well as sickle cell have more avascular necrosis. And that's just one of the explanations we think explains why some people get AVN and some people don't get AVN with their sickle cell. So it's not always about the sickle when you think about sickle cell disease.